I'm going to guess that many people will know exactly what I'm going to say. So I can keep it very, very short. I'm very excited to be here. It's a very interesting conversation so far, and I'm very happy to be talking to all of you. And thank you very much for training the people that we need to power our future. So just a little bit more about me and where I come from. I lead data science at the Climate Corporation. And the Climate Corporation was a startup working in the intersection of data and agriculture. And we were acquired by an agricultural company named Monsanto in 2013. So now I work in a much larger organization doing data science there as well. And I think we're living in an age where people have very high expectations that data is going to generate a lot of tangible value in their lives. We interact as consumers with products on the web all the time, and we develop all kinds of high expectations. The next generation is going to have expectations that are even higher, I suspect. And that's true also in many, many industries. We heard from some of those industries this morning. And that's increasingly true in agriculture. In many ways, statistics was developed for agriculture, going back to Fisher. Farmers have not stopped seeking to find answers from data. And we, at the Climate Corporation, we build products for farmers to draw inferences from the data they have and data they don't have to make day-to-day decisions. So I wanted to reiterate, and then maybe we can move into the discussion and go into more detail, reiterate a lot of the comments that were made earlier. So I thought it was interesting that none of us had, this is an IAD set in some sense. None of us had collaborated before on comments, but there's really certainly a theme. And that theme, I think, is around interdisciplinary work. I think of myself as a data scientist. I'm not trained in statistics, although I play one at work in many ways. I have a background in computer science and a background in mathematics. And most of the work that I engage in and that we engage in my company at least, is very interdisciplinary in nature. And we find the magic happens when you connect discipline A to discipline B to discipline C and get those individuals in a small room, give them an interesting problem, and see what comes out of that. And typically, that activity ranges the span from software engineering, which includes getting the data. You don't get very far if you can't get the data. And most of the times, the expectation is that when you explain at a high level what software system has the data, that the person who needs to analyze the data can get access to it on their own. It is the process of iterating and collaborating as a group. And I think I would break down communication into two different areas, the first of which is collaboration. And these interdisciplinary interactions, communication is vital as a force of collaboration. So you have to collaborate with software engineers to get the data, for example. You have to collaborate with people from maybe different academic disciplines. They may be subject matter experts in the domain in which you're working, say a biologist or something like that. And then, of course, there is the understanding of the business need and the application. And in my experience, I found that oftentimes the business doesn't know what they need. They have a lot of data. Some executive believes there's a lot of value in the data, or the board has read something in the newspaper about artificial intelligence or deep learning, and they ask someone on the executive team, what are we doing in this area? And they don't really know exactly what that means, but they know that they understand that it has some value, and they want to make sure that they're not missing out on that value. And so any skill in communication in terms of elicitation of the actual need, communicating in the business language to understand what exactly is to be done to create value at the end of the day is essential. And then the other aspect of communication that I just wanted to reiterate is in terms of influencing, and this was said before. Most of the time, some data will be consumed and analyzed with the intent to influence something, and typically influence a decision. And it's very important that that influence use the right be derived from an analysis using the right methods, and that things have a soundness and a rigor behind them, but that's certainly not sufficient. It's necessary but not sufficient to ultimately have the impact that's needed. And so the other aspect of communication that I would challenge us to think about is communication as a means to influence decision makers, and to, and more importantly, to communicate effectively so that they make the right decisions on the basis of whatever the data suggests and the methods suggest. And one other comment I wanted to make, because I think it's an important thing to think about, is what is the role of statistics in this big data world we're in? And I think there are a few roles. I wanted to reiterate some of the comments before about design being important. I think that's one aspect. I think as we see data applied to more and more domains, we are increasingly seeing more and more decision makers who are consuming these data products start to ask the question, why? So your model says I should do X. And in our case, we have a predictive model that tells a farmer how much fertilizer they should apply. And historically, their grandfather did a certain thing, their father did a certain thing, and now here's this person from San Francisco. I'm from San Francisco. Coming to tell me that my grandfather and father were wrong, and I should do something different. The first question they always ask is why? And if you have a black box model, you oftentimes can't answer that question. Well, there's a machine that says to do it, and I think the machine's right for your case, but maybe it isn't, and by the way, it's your $1 million on the line that you're spending on the fertilizer, not mine. But take my word for it, because I'm from California. And I'm here to help. One can imagine how that conversation goes, and it doesn't always go well. But if you can answer the question why, and you have models that are interpretable and explainable, and more importantly, you have the communication skills to interpret that model in the language that's relevant and in terms that the stakeholder understands, you get much further in that conversation. So that's, I think, one extremely important role. In some places there is a lot of data, but typically it provides part of the solution but not all of the solution. So what do you do when you have a really big data set and then you have a bunch of other data that's relevant but not as big? You can do some machine learning on the big data, and that usually works pretty well, especially when you can test it very quickly. But what do you do when you have a bunch of other data that's relevant that's not very big? Well, then you need to be careful. And you need to think very carefully about what type of model you're building. Maybe there are some parametric methods that are appropriate. And that allows you also, I think, which is another role of statistics, which is to add information to the problem. You can use some of these non-parametric machine learning methods on big data sets and just apply the method and cross your fingers, and that works reasonably well a lot of the time. But oftentimes you know a little bit more than just that. You may know something about the domain, for example, and you could apply that information you know about the domain when you're constructing the model in a parametric form. And then the other area that I want to think about in terms of providing skills that we need in industry is thinking about statistics as skills for leadership and organizational skills. So as students go around and play in everyone's backyard, they interact with different domains. Hopefully they're gaining experience leading projects and doing that type of work. And also hopefully they're getting experience leading in formulating the right questions to ask. So rather than just take a hypothesis test that's kind of given from the sky, but asking the right questions to help improve ultimately the outcome. So that's all. Looking forward to a very interesting conversation, and it does seem to be some theme this morning.